In computer science, there are a lot of ways, a lot of algorithms to sort things. You might have heard of them. And I want to make one, not in code, but in Minecraft. Why? I don't know. I really want to find out if that's possible and if I manage to do that. Okay, which one do I pick? Bubble sort sounds interesting. It works by comparing two values next to each other. If they are in correct order, nothing happens. If not, you switch them. So the 7 bubbles to the right. Bubble, bubble, bubble. To be completely honest, I don't know how to build this, so you will see my exact thought process in all of it. So I have picked all of the rules. Let's start with the redstone. To be honest, I don't know what we need exactly. I'm not that great in redstone, so this might be a problem. Let's take a level as well. We definitely need hoppers and chests. So right now I'm just building up because we probably need some space to build all of it. Okay, that should be high enough. Let's break all of this. Let's just build a first platform here so I can place some stuff without having to go down. Of course it starts to rain. How do I clear the weather? Weather clear. Clear? Yes, of course. So before we now build anything, I will take the time and actually plan out something in advance so I won't fail completely and have to rebuild everything. Okay, this is the plan. We have here our different colored wool blocks, red, yellow and orange, and we want to sort them using bubble sort. So how we do this is that we take the first two colors, we do that with some redstone. Yes, right, okay. And if we do this redstone thing here, we should be able to get those two wood blocks and compare them like here. And after that, we need to get two signets. If they are in correct order, then we do nothing. And if not, we have to do something here. Let's just build this first part where we store all of the wool in chests. And then we can release them and check them against each other. Okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. One less. Okay, then we need chests and some wool in all of them. I probably just want one wool. Yeah, so let me quickly see how this works. I believe if you connect a redstone signet to this hopper, then it shouldn't be transporting blocks from this chest into this chest. So right now it should transport that wool block. Yes, it does. Okay, and now I connect a redstone signet to it. And it doesn't transport it. Perfect. Does it transport this? It's completely disabled. That's great. So I have now powered all of the hoppers. So in theory, the wool block would be still in those chests here on top. And they are. Great. Do not worry about those levers. Those will be temporary. So according to my genius drawing right here, the next step is to leave the wool out of those chests and compare it somewhere here. Let's name this C or compare. And I would say we only build this once and use it for all of the comparison. I stumbled on a problem. I don't know how to compare those colors. Depending on your goal, comparing items in Minecraft usually means either testing if the two items match in common. I don't know if I want to do this, or checking item quantities. I especially don't want to do this, so it might be the first, or I have to do something different. First, by item type or NBT text in Minecraft comments. Let's skip that. Second, by quantity. Also skip that. Three, by exact code. Okay, this probably won't be it. This sounds good. For example, to check if two stacks are entirely identical in code. Wool. No, or visual guide. Okay, it shows this. This looks good.
Hey everyone, welcome to Nim's Tutorials.
Crazy, this is exactly what I need. Okay, this is a good frame, like this. We need redstone here and here. Okay, then we need a thingy with 2 and a thingy with 3. Repeater and comparator. The repeater on the bottom and the comparator on the top. Then we can place a chest here, like this. Next, we said we should use signs. Let's do that. In slot 2, 3, 4 and 5. It doesn't work. Okay. I forgot the redstone torch right here. Okay, let's try it again. Redstone torch on the bottom. I broke it. Great. And now try number 2. 4 signs in slot 2, 3, 4 and 5. It works. And then I need some wool right here. Okay. And apparently I can now drop it in here and it should come out here, but no other items. Okay. It's 6, like the tutorial told me to. Yeah, exactly. That wool is down here. And now if I should drop some other wool on top of it, it shouldn't be picked up exactly how it's supposed to work. So we just have to build this 8 times because we compare 8 wools and we have to, wait, let me think. Yes, we basically have to, okay, here's what we need to do. We need each of those wools, get to a stream of 8 of those compare thingies in a row. And then let's say we first compare with red. We do that. And if the item gets picked up and we know it's a wool that goes through here and we can make a redstone signal like this. Yeah, it goes here and we know, okay, the wool we have right here is is the red wool, and then we have to check how far those woods are in the bag. I believe it makes sense. Just let me build it and you will see. So in theory, the item gets from the hopper into the dispenser, gets pushed along this way. Down here there are hoppers that pick up the item every 2 blocks, and some ice right here, so the item should slide to the end. So basically we have those 8 hoppers right here, and we have to build this contraption with the hopper right here on top 8 times, and this hopper will be this hopper every time. Under the hopper there has to be a hopper to a chest. Hopper is facing this direction, so I believe the direction of the hopper down here is not relevant. I hope so. So in theory, the sorting system we built here will already be sorting those wood blocks in the perfect order. But I said we won't do this because it's just boring. So this is the first redstone. So here, this has to be the repeater. So we need a block here. Oops, this was a comparator. And I believe it's done. It should work. Now we have to fill each of those hoppers with the signs. This is the first hopper. Okay, the same thing happened again. I forgot to power those hoppers, of course, with the redstone torch. Okay, and the redstone torch has to go down here. Where is this contraption? Here is a block, and there the redstone torch. Yes. So, and now the signs shouldn't disappear. 2, 3, 4, and 5. And it works. Perfect. And now we just have to fill up each of those hoppers with the wood blocks. And it stops at exactly 6. So it's perfect. Let's get those blocks back so they don't disrupt the system. And fill back in the water. This should work. So and now we just have to connect each of those chests with a hopper with a complete system. Let's make a test run. I will drop some red wool in the first one, or I will just unpower that redstone. And in theory, it should come out in this chest. Unpower that. Should be gone here. Yes. And in this chest now, there should be a red wool. Okay, there isn't a red wool. That's a problem. There's one here. There's 6 here. Okay, I found the missing part. This of course isn't triggered. So we need to do that. Now let's do it with a lever. Now it's pendant, and it should be here. It works. Perfect. But if I drop some magenta wool in this chest back there and not in any of those. And it's right here. Perfect. Let's fill those up again. For you a red wool and for you a magenta wool. Okay, let's quickly come back to the drawing board and erase that. Check mark. Maybe it's a bit big. Let's make it small. Looks real. Also looks real. Perfect. I have updated the drawing a little bit, and now we have those 8 places where the wool goes, and we have to figure out how we go ahead after that. Okay, if that's a red wool and the second one is a yellow wool, that comes out here. Okay, the way you would do this in code is you set those numbers. This is value 1 and this is value 2, and then you compare value 1 with value 2. In this case, red is smaller, so it's like this. Value 2 is bigger than value 1, which is true, so we don't switch. Let's also draw the value here, 1 and 2. And 2, those are these numbers. 2 is bigger than 1. If that's the case, we can just get those colors back and place them in here. Because we took them and we have to place them back. Yes, before we do that, we should care about this right here. We should compare them. How do we do that? I believe that is the point where we use the strength of the 2 redstone signals and compare those, because we can probably give those redstone signals a strength of 1 to 8. 8 would be up here. And when we compare those two, we can keep track of which value comes from which wool, from the first or the second, with this or this. And by that, we compare those wools right here. Comparing, we can do this with the comparator. I know that we can do this, but I don't know how. After we compare it, either it's smaller or bigger, and then we either have to get those back in the original position, or we have to switch those. Okay, get wool back. This will be my task for tomorrow, because I've had enough math and wool for today. Then it's been the next day. You can see I've updated all of this so that your little googly eyes can enjoy all of it. And totally not because I've accidentally did everything yesterday. No, of course not. Wouldn't be me. For our first comparison, we have red wool with a value of 1 because it's the first in the rainbow. Yellow wool with a value of 3 because it's the third in the rainbow. Now we have to transform this into a redstone signal with values from 1 to 8. Of course, we already have the values right here. So we just have to figure out how we get those values to appear. After that, we can compare those. In this example, value 1 and 3, we probably need a comparator, and I actually don't know how to use a comparator, so this will be a challenge. And then we just need to make 2 different decisions based on if this sign is smaller or bigger. But let's start with converting our values into redstone signal strength. What I think we need is to build a contraption that picks up the item right here. If it does, it sends a redstone signal compared to a first, second, third, or fourth, and so on. And it has to be value from 1 to 8. Power redstone with a specific strength ranging from 1 to 15. We only need need 8. You can use a redstone comparator, of course, to measure the state of a block, construct a container with a precise amount of items, or simply adjust the length of the redstone wire. I've heard of this. You can basically, with a comparator, create different amount of strength in redstone, depending on how many items there are in the stack of a container next to the redstone comparator. The first is distance base. I think we skip this. A lot of effort for 8 different ones. Item base, container, thickness strength. Yes, that's what we need. Redstone comparator generates a thickness strength proportionate to how an inventory block is. The lectern outputs a specific thickness depending on the page of the book it's open to. The lectern is it can hold a book. For example, page 1 outputs thickness 1 and so on. That's easy. Test and barrel. Yeah, but it doesn't say how many items you need for which thickness strength. I think I'm gonna use the lectern. Okay, we have our 8 streams of items right here. And depending on which rule we have, use a different lectern, triangle lectern, or all of them like this and so on, which outputs redstone signal and connects to the comparator and gives output on which is bigger or smaller. We need to connect all of those, but I believe if we connect this to this, then that's really long and it would lose power. So here thickness strength 1, but here's in 0. Every block the redstone line goes on, it loses 1 thickness strength. That's hard. I don't know how to do this. I believe, yes, I know what we can do. We have to do it twice. Like we first decide on which item we have. Wait, let me try this a little bit. Okay, right here. We have 8 of those lecterns that output the thickness strength. Depending on what thickness strength we have, we put a different amount of blocks into a container. We probably need containers at this point. Let's remove this. We need a container. Let's say this is a container chest. And this right here is also a container. And when the first rule comes, in this case it's the red one, it has a thickness strength of 1. It somehow makes it that in this chest there are only so many items that this is a thickness strength of 1. And then the second rule comes and goes through this line. It makes so many items in this chest that is the thickness strength of 3. And in this line decide if it's bigger or smaller. Now we have to figure out how to build this. To calculate the exact number of items for a specific thickness strength with the formula. Yeah, no way. We just look at this. Okay, but it doesn't say from 1 to 8. It skips some. Great, right here. Minimum items for container thickness strength. We want less than 1 to 8. So these stacks plus 55. We only need the first 8 right here. Let's start building. Okay, this is my problem. I have a temporary redstone signal from here. And if that's activated, we only count what this has right here. Because we right now have the first rule. And if it's deactivated, then we count for this. But I don't know how to make a deactivation. Well, T flip-flop. I need a flip-flop. How to make every T flip-flop in Minecraft. By Mambo Jumbo. So I probably don't need every, but maybe the simplest. Okay, I probably need this. I have an idea. Maybe I can even make it automatically. So when the first rule comes from here, it activates the flip-flop. It causes it to be the first item right here. And then when the second item comes, the flip-flop is activated. So it deactivates, but it makes go through this. And then we have the 2 values. So I believe when the first item comes from here, I can detect when it goes through a hopper. Because there is something like a dispenser or observer. I believe it's an observer. Observer. Yes. I have some hoppers right here going in this direction. Test right here. And we have an observer. It's basically looking at the hoppers like this. So it should output a redstone signal and an item goes through. If I put an item right here, it goes through the hoppers. The observer recognizes that it goes through this hopper and outputs a redstone signal. And this piston should extend. If it extends, and now I'm correct. Let's give it a sign. Okay, it didn't work. It's a problem. I think I found something. If you place one rule in here, like it could from any of those hoppers, then this extends. One line rule, and it extends. Great. Let's place this down here as for the second and make a stream of hoppers right here. So the plan is that all of the items go through this hopper, go through here into the chest just for the moment. But we can see when it goes through here, it detects it, and we can activate the flip-flop by that. So I just need to build this right here. The piston is under the redstone, but the repeater is also at the level from the redstone. So if we now place the item right here, this hopper, it should activate it. Place one line rule, it's activated. If we drop another one, it should deactivate. It didn't deactivate. Again? Oh no. Please. Drop 2 line rule. Why doesn't it deactivate? This won't activate it. Ah, you can right click on it and it transforms. Maybe that's the reason. Let's reset it like this. And that's not a sticky piston. It probably has a sticky piston. It wouldn't make sense. A sticky piston makes sure that when it goes back in, the block sticks to it. When it goes back in, it puts the block right into it. So down here again. This could change it. And the lamp didn't activate. Okay. This has to be a sticky piston, right? And it's out. Yes, it only took 16 tries. Final test. I put one in. Okay. And I put in the second one. and goes out. Yes, this is then constantly powered. If we put in another one, it's constantly off. Wait, okay, we are here, and we have this redstone signal right here. So this redstone signal decides if we set the value for this test or for this test. But first, we still need to make sure that we get the redstone signal strength depending on which tool got placed in. And we would do this right here, I believe. I have redesigned all of this, or at least some of it, so that all of the items go through here, this way, this corner, and through here. And then they go on in this direction. In between the rest, I've built a contraption so it recognizes when the item goes to this hopper, and I will build it for this, and between all of the other chests. And in the end, I have a redstone signal, 1, 2, 3, 4, and so on. And it's, for example, the red tool. I know it, and all of those redstone strings right here, they go on. And if those all go on, I can then make logic so that right here in our beautiful drawing, we know that this is the red tool, and it has the value of 1. Oh, we give it a value 1. I will have to decide on this later, but this is the plan for now. So I've built all of the redstone lines right here, all of those, and I've connected some rules so we can see which are power. But before we care about this, I would first look into how we can compare to redstone signal strength with the repeater. Okay, I'm back at the wiki for the redstone comparator, and where is it? Need compare. Redstone comparator in comparison mode, front torch down and unpowered. What does down mean? Compares its rear input to other side inputs, like this. This is then the rear input from behind to side inputs, like this. Then it compares, probably like this. If either side is greater than the rear input, okay, we just use one side, the comparator turns off. Okay, let's test it. I have redstone signal here, which is longer, and I activate it. Because it's longer, it should have less power right here, instead of just activating this. If this is greater, it should turn off. Okay. It was off, I don't know. Let's just do this fast instead. We need 2 more comparators, one here and one here, and chest. Okay, I built a sticky piston right here, so we see if it turns on. Let's add a bunch of items right here. Didn't do anything. Okay, this signal is on, but this is off and it does nothing. Let's add some right here. It also does nothing. Maybe if I add one right here. Let's look at the picture. E is longer than A. Ah, the rear side is with the 2. Okay, like this. The rear side has more, so it powers. But if this has more, it powers off. Okay, so this is our comparison if one value is bigger than the other. Let's write this down so I don't forget it later. If the rear value, so this value, is bigger, it means it's powered on. And if this value is bigger and this is smaller, it's powered off. Okay, we have to make sure that the first rule goes through here, makes whatever signal it is, depending on which color it is, and this loads this chest, and the second loads this chest using the flip-flop. Okay, let's drop some magenta wool right in here so we can see how long each signal is active. Mistake, it powered this one, and it wouldn't power this one, it only powered this one if it's magenta wool. Dark blue should power this one and this one, light blue this one, and this one, but magenta wool should only power this one, and it powered this one, which is wrong. It's probably because it goes into this hopper right here, and this hopper also powers in this repeater right here. Okay, let me quickly test if we can't just use those redstone strings right here, because there's also a comparator, and this wouldn't make the interference effect right here. Yes, it gets power. I don't actually need this one, and I have to break it again. Wait. And the advantage of this way is that only one gets powered. For example, in the earlier version, if we put in red wool, all of those would have get power, but now only one. Okay, the next step is now that we need to fill each of those tests depending on which wool got placed in. If the red wool got placed in, we only fill the test so it gives a strength of 1. If the orange wool was placed in, then we fill the test with a signal strength of 2. Yellow 3, light green 4, and so on. So how do we do that? Can we use items that fill up a complete slot? Now I place 2 slots in here. It deactivates, okay. So we can use this so that if the red wool gets placed in, we need a signal strength of 1, so we only place 1 slot in here. If the orange wool gets placed in, we place 2 slots, and so on. We can use a dispenser, and dispense it so often how many slots we need, and those all land in the chest on the bottom. Okay, I can demonstrate it right now. I have a dispenser with slots in here, and if I place a button, and depending if it's the first red, second orange, or yellow, we can activate it that many times. For example, 1, red, orange, yellow. And there are here 3 items, so it should be a power of 3. No, wait, we have a problem. This works for the first one, but for the second and so on, it isn't directly power level 2, 2 stacks, power level 3, 3 stacks. This breaks my complete idea. Is there any other that we can use? Yes, right here, the crafter. It has power level 1, 1 slot, power level 2, 2 slots, power level 3, 3 slots, and so on. I've never used the crafter, but it should be exactly the same as the chest, just with 9 total slots. And it can crafting, which we don't need for this scenario. My idea should still work, right? I can simply add one right here. Okay, but can I delete one out of it? wool with a hopper, like this. Yes, I can. Great, but still works. Okay, when the red wool gets placed in here, activates once, which is perfect. But if the orange wool gets placed in here, it also only activates once, and we want it twice, because it's the second item. How do we do that? Okay, so I believe I have found a way to make it work. Red wool in here, it goes through here. This is the one-way gate, so it doesn't go here. It goes up here, and for this case, only extends the piston. Later it will place swords in our crafters, so it only extends it once. If we place in the orange wool, it also activates this with a time delay of a second or so. This goes up, goes through here, activated, and then the time delay kicks in, and we activate a second time. Okay, it should now only extend once. It doesn't, I don't know why. Maybe it's too weak. Okay, I have to fix this, whatever this is. It should work if you place a repeater right here. I hope so. It doesn't. Okay. Okay, it works for orange, but it doesn't work for red. It should be the same. It doesn't work. But for orange, it does. Why? Wait, there are only 2 red wool in here and there are 6 in here. And there should be 6 in everything. Yes, so there was something wrong. So now it should work? Yes, it works. Okay, if I drop orange in it, and it still does too, right? Yeah, so I'm now going to build for all of the 8 colors. Okay, another quick test for yellow. Okay, it works perfectly. I just had to extend the delay right here. So for this one, it gets pretty long, but it should work. OMG, it will take so long to sort all of it if I had add so much delay. But after all, it's not called big sort, it's called double sort. Okay, it's done. It looks absurd, but let's try it out. So if I put in magenta wool, it should extend 8 times. And 8. Perfect. I'm a redstone genius. Okay, that works. But if we now connect them to the dispensers, it doesn't, because we want the first wool to dispense however many times we want it to the first one, the second wool to this one. We need to check if it's the second wool. For that, we've already built a flip-flop, but now we have to connect it so it properly works in our system. So how do we do that? First of all, we should build a staircase for this redstone signal to even interact with this redstone signal. Okay, by default, we can just take this one, make it go down here, and it connects. But for the second one, we need something right here. A redstone repeater can send a signal through a block. But if we push that block away using a piston, then it shouldn't work. And there is no signal through here. Let's say the flip-flop is deactivated and there is a signal coming through here. It goes through here. But if the flip-flop is activated, then it doesn't go through, right? Yes. Perfect. In that case, we take it from here and can connect it through there. But if we do that, then it always connects to this, no matter if the flip-flop is activated or deactivated. So we have to build this one, but in reverse. So if the flip-flop is activated, only then the signal goes through. But if the flip-flop is deactivated and this goes through here, this doesn't go from here to this. Okay, let's say this flip-flop activates like this, and there's a signal coming from here. It shouldn't go here, but it should go here, right? Yes, it wasn't here, but it was here. Now let's connect this and this redstone line with the dispenser. Okay, let's try it out. The flip-flop is deactivated, so this is deactivated, and the red wool is coming. So it's just one activation. There should be one sword in here. Yes, but now the yellow wool is coming, and there are 3 signal activations, but also the flip-flop is activated. 1, 2, 3. So now there are 3 swords in here. There aren't 3 swords in here. Why? There's this all swords in here. Maybe the signal is too long. Could it be that? Let's try again. 3. This time I think I heard a dispenser, and there are 3 swords missing here, and there are in here. So there are more in here, which means this is disabled. So it works. So this done. This is also done. Okay, we have completed step 1 and step 2. Now we just need to get the wool back in the test, and that depending on if the result over here was bigger or smaller. So right now our wool just gets stuck in here, and it doesn't go any further. We also need to separate them, so we should probably use the flip-flop. But first, let's connect it to the main system. So okay, I've now hooked it up to the main system. How to separate items that go through hoppers in Minecraft. I think I can get a quick but dirty solution for that by myself. I think I have a solution actually. It isn't quick and dirty. Or it's quick, but it isn't dirty. So okay, those hoppers on top face in this direction, and the hoppers on the bottom face downwards. If I now place an item in this hopper, where will it go? It's not here. It's here. But this hopper actually is faster. So if we want to make a separation, we should actually power this hopper. Let's do that. Now this hopper is powered and it shouldn't pick up items hopefully. Now I place the same lime wool here and it's over here. Perfect. It works perfectly. Okay, we have our upper row over here and our hoppers that face downwards here. Okay, we have now our 2 points where our wool blocks will be stored before we put them back in our chest. But how do we continue after that? How do we know where to put them? We probably have to keep track of where we took them from. But how? Okay, the way you program this with code is that you remember where you got your rule from and then just place it back. But we obviously can't do this. So the only way I have is that we use some minecarts with hoppers in there so we can transport items. Okay, I will build a quick explanation so I can show you what I mean. Okay, the first thing that I have done is that I extended the system and now the redstone signal that blocks this hopper also blocks this hopper. So if we now were to compare the first two items, those two would be deactivated. After we compare the wool blocks, they are in those two hoppers and we just need to get them in this minecart. Because if we compare the values and we know that we need to get the wool in the original position back, then we just take wool number 1 and move it along in this direction. Because all of those hoppers here are powered so they won't pick it up, and if we move it from the left, the first hopper who can pick it up is this one. Now in reverse, if we know that we need to switch the wool, we just move it from the right with the first one. Because in moving it from the right means that we always place it in the one that we didn't get it from. And after we have placed in wool 1 and this is full, we can take wool 2 and move it also from the right one, and all of those hoppers are powered so it won't get picked up, and the only hopper that can pick it up is the left one. And that one is the one we didn't get it from, so we switch wool 1 and wool 2. But I'm going to build this tomorrow, because if I continue any longer for today, I will probably have very bad dreams tonight. So see you tomorrow. Ladies and gentlemen, good morning, or should I rather say terrible afternoon. I spent the last 1.5 hours continuing building all of this. Problem number 1, I got stuck at something and I don't know how to fix it. Problem number 2, I forgot to press recording. So I guess I have to show you everything I built in those 1.5 hours. The first thing I did was to build a rail system, so let me show you how it works. We have a hopper minecart that can pick up items. The first wool block, which is in this hopper, gets placed into this minecart. This minecart then drives up here, collects the second wool block, and it takes a big loop. And depending if it needs to drive from the left or from the right, we can switch the rail. Like this. This redstone signal is hooked up to our comparison over here, which compares the values of our wool blocks. Then after it's switched in the right direction, it drives along. Over here, down here, along here, and get stuck. If we then need another minecart, we can just activate it and it will drive, collect it from here and up there, and the cycle repeats. Oh, and I also placed those blocks right here because the dispenser dropped them too far and they wouldn't get picked up by this hopper. So let's make a test run to see what works and what doesn't. We have first some wool in this chest and yellow in this chest. Then we deactivate this lever and the red wool is in here. Then we dispense it. It should activate this right here any second. Yes, and it should be in here. Yes. Also, it should have loaded this rafter with one sword because red is the first color in the rainbow. This is also correct. Then we activate the second color. It should be in here. Yes. We dispense it gets picked up, deactivates this flip right here, it's in here, and it should load this crafter with 3 swords because yellow is the third color. Perfect. Now this comparator works because if the rear side, so this side with 1 sword, is smaller than the other side with 3, 1 is smaller than 3, the signal is off, and it's off, which means this rail points to the left, and that's correct. If it's smaller, we need to sort from left to right, and we do this by going over here, up here, and then this, and then this. If we would come from the right, it would first be this, and then this. So let's send the minecart. This is temporary, but we will fix this later. Fix it up the first, second, goes up there, up here, and from left to right. So let's deactivate this. So in theory, the red wool should be in here and the yellow wool in here, because it first picked up the red wool and the first hopper who could pick it up was this. But it's empty. Of course, the red wool and the yellow wool are in here. Or if it's deactivated, the hopper immediately picks it up again and delivers it to the dispenser. The way to fix this would be to build 8 flip-flops, like 1 for every single color. Exactly those flip-flops we build right here. But to be completely honest, I don't think there's much of a change in doing that, and it would bring in so much more complexity for you and me, so I'm just going to skip this. I'm just going to split this so every single of those 8 stations can be controlled with 2 levers. Okay, for each of them we now have 1 lever at the bottom and 1 at the top. So our example works, we just need to fix 3 things. Number 1, whenever we load swords into here, those don't get empty. Number 2, when we load swords into here, we have to send a redstone signal down here, so the minecart picks up the wool. And number 3, this dispenser isn't automatically. We can immediately fix it with a clock. This should fix it because if you put an item in here, it gets delivered to here, which sends a redstone signal to this. And this hopper brings it back here, which repeats the cycle. It should work like this. Yes. Second, this redstone signal has to go down here to activate the minecart. Problem, the signal isn't long enough. How to extend redstone signal to be longer active. So this should work, I guess. Yes, perfectly. And it goes out in time. I have quickly extended this so it doesn't go click, 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 click. The loop now takes longer and the clock is shorter. Okay, the only problem left is that those doors don't get emptied and they don't get refilled after a comparison. Okay, this signal is constantly on, but as soon as we press this button, this piston pushes the block away. It causes the signal to be off because there is no block in this way. Now we need to build a clock here, so if the signal is off, there is a repeating short signal, but only if we press the button. Like we wanted to. But this isn't long enough, so we need to extend it like we did down here. Now if we press the button, the piston should extend for longer and the clock has more time. Yes, perfectly, but let's quickly connect this button to up here. And I believe we're done. This should be everything. I will now test the final twirl. Down in the hotbar, you can now see the order in which I have filled the test. And after we have sorted them, they should be like a rainbow. Okay, the first step is to compare the first two rules. In this example, they are red and yellow and they're already in the correct order. Let's click those two levers so the rule can get delivered back and give the system the first rule. Okay, it works, the sort is loaded. Let's give it the second rule. And then it automatically should work. And here comes the minecart. And hopefully I have clicked those levers in time, so there should be a red rule in here and a yellow one in here. I clicked the levers a little bit late, but it was still in time. I will move them up here. But it worked. Now let's compare item 2 and 3. So we sorted yellow and magenta. Now we need to sort magenta and light blue. It comes from the left. It should come from the right. And it does. So right here there should be light blue rule and here magenta. Magenta, light blue rule. Perfect. Now we need to sort this magenta and this green. And it should again come from the right. And here it comes. So hopefully this is really over. Please, let it be over. This should be red. Yes. This should be orange. Yes. This should be yellow. Yes. This should be green. Yes. This should be dark green. Yes. This should be blue. Yes. This should be dark blue. Yes. And this should be magenta. Yes, we did it. Finally. Okay, now that we know that it works, the next step would be to edit that we only need to press one button and everything works automatically. Oh hell no.